Hello, Precalculus students. This is a review for the final exam created by the Rutgers University Math Department. According to the description for the final exam, it will be in two parts. The first part does not allow the use of a calculator. The second part does allow the use of a graphing calculator. So throughout the review, if we see that calculator symbol next to the question, it means that you would be permitted to use a graphing calculator on your final exam for those types of questions. So the first question states, sketch the graph of the following. Using interval notations to state the domain and the range, state the equations of the asymptotes. Find the x and y intercepts where they exist. So looking at question A, it shows an exponential function. And we know this because there is a variable in the exponent. So first, let's find our asymptote. So if this was a basic exponential function, meaning that it's not shifted up or down, then it would be approaching the line y equals 0. But this function is being shifted up 4 units. So that asymptote, that horizontal asymptote of y equals 0, shifts up to y equals 4. So this added constant will always be your horizontal asymptote. Okay? So now, for the x-intercept, your x-intercept is where y equals 0. So we can plug in y equals 0. Now, before we start solving, we actually know that this should not exist because this is an exponentially growing function because the base is greater than 1, and it approaches 4 as x approaches negative infinity, but it's going to approach infinity because it will be strictly increasing. So let's see if that's what we get. You could subtract 4. Now I have negative 4 equals 3 to the x minus 2. Then I could take the log base 3. My argument, the argument will always be on the other side of the equal sign. Negative 4 equals x minus 2. The next step would be to add 2. Now something about the argument of a log, it cannot give you a argument that is equal to 0 or negative. Because think about it, logarithms just extract the exponents, right? So an exponent is essentially saying how many times you're multiplying a number by itself, how many times you're dividing a number by itself. And you cannot divide a number that is non-zero and get 0. So this does actually not exist. But we could have known that from the horizontal asymptote or if we were to sketch this. Now for the y-intercept. A y-intercept is where x equals 0. So we're going to plug in 0 for x. So 0 minus 2 is negative 2. 3 to the negative 2 is just the reciprocal of 3 squared, which is 1 over 3 squared. That's what a negative exponent does. A little trick, if you ever see a negative on the exponent, make it 1 over. Plus 4, so that's 1 over 9 plus 4, which is 1 over 9 plus 36 over 9, because 36 over 9 equals 4, which would be 37 over 9. That would be your y-intercept. Now let's do a quick little sketch. We said that there's a horizontal asymptote of y equals 4. So let's use a dotted line to show the horizontal asymptote. We said it's exponentially growing because the base is greater than 1. And we also said that the y-intercept was 37 over 9. 37 over 9 is approximately 4.1. So about there, we'll say. And we said it's exponentially growing. And from the left side, it approaches 4. But it will never touch 4. So now for the domain and the range. It will forever continue in the left direction. It will forever continue in the right direction. A domain is all the x values that a function exists on. So that would be negative infinity to infinity. We use parentheses because we cannot define infinity. It is not a definite number. It continues to go on and on. Now for the range, it starts at 4, even though it doesn't actually equal 4, and it would keep going up forever. So that's 4 to infinity. But since we cannot include 4 because there's a horizontal asymptote there, which means that it approaches but never touches that line, we have to use parentheses because the function will never actually reach 4. The same thing for infinity. It keeps continuing, but we cannot define it at infinity. So that was the sketch with the horizontal asymptote, the x-intercept that didn't exist, the y-intercept, the domain, and the range. Now let's do question B. Question B, it says f of x equals ln of x minus 2 plus 3. This is your natural logarithm. Logarithms are the inverse of exponentials. So where exponentials have a horizontal asymptote, logarithms have a vertical asymptote. And the way we solve that is we set our argument greater than 0. Remember, logarithms are extracting your exponents, and exponents cannot, for a non-zero number, divide and ever give you 0. This is why it has to be greater than 0. It also cannot give you a negative number. So we are going to add 2. And what we just found is actually your domain. So if I said the set of x such that x is greater than 2, that's your domain in set builder notation. The question asks for interval notation, so let's give it an interval. If x is greater than 2, that means it doesn't equal 2. And then it goes greater than 2 to infinity. We use parentheses because your vertical asymptote must be at x equals 2. And we use parentheses around the infinity because you cannot define infinity. So now let's find the x-intercept. Again, an x-intercept is where y equals 0. So we're going to plug in 0 for y. Okay. And now we can subtract 3 on both sides. We get negative 3 equals ln of x minus 2. The reason we do this is to isolate the ln. And then there's two things you could do. You know that in order for ln of x minus 2 to equal negative 3, the argument has to equal the base, and ln's base is e, to the negative 3. So you could say x minus 2 equals e to the negative 3, and then just add 2, and that's your answer. Or you can do the inverse of ln, which is e to the x, on both sides, and then you get e to the negative 3 equals x minus 2, and add 2. Notice that it's essentially the same work, and you get the exact same answer. You could also show this as 1 over e to the 3 plus 2. Just to get the numeric value when we do our sketch, I will put this in the calculator. It's approximately 2.04978768. So 2.05, it's approximately. So that's how you would find your x-intercept. Now for the y-intercept. And very similar to your first question. So in y-intercept where x equals 0. Very similar to the first question. Your vertical asymptote's at x equals 2. So we know that this y-intercept, it's never actually going to touch where x equals 0. So it's not going to exist. But if it was shifted to the left rather than shifted to the right, it could exist. So I'll show you the work for how to solve for the y-intercept. So y-intercept is where x equals 0. So plug in 0. ln of negative 2 plus 3. You could put it in your calculator or just know. You just ungroup that. Or just know that the argument of your log cannot be less than 0. So f of 0 does not exist. Okay? So let's start sketching this. The vertical asymptote is at x equals 2. We know that the x-intercept is at about 2.05. Your logarithm looks something like this. Okay? So since C and D are very similar practice problems, I'll leave that for you to practice. Let's go to question 2. So, given log base A of 5 equals 2.3 and log base A of 3 equals 1.6, fill in the table below. So, it looks like the function is log base A of x, and they're giving you these x values. Now, they gave you an input of 5 and an input of 3, and I know that 15 equals 3 times 5. So, with logarithms, if you are going to, let's say, log base A of 15 equals log base A of 3 times 5, if it's separated by multiplication, you could separate your logs by addition. That is called your product law of logarithms. Okay? So, log base A of 3 is 1.6. Log base A of 5 is 2.3. You add those up, and you would get 3.9. Now for 9. For 9, you could do two things. You could either show it as 3 squared or 3 times 3. For the sake of showing a different law, I will do the 3 squared. So log base A of 9 equals log base A of 3 squared. If you did 3 times 3, you would just do log base A of 3 plus log base A of 3. But now I have an exponent in my log, so I could use my power law. Your power law allows you to bring the exponent to the front separated by multiplication. So 2 times log base A of 3. We said that log base A of 3 is 1.6. Which is 3.2. Now for 5/3. We want to find log base A of 5/3. And if you have division in a log, you could separate it by subtraction. So it has to start with the numerator, and then you subtract it with the log with the same base of your denominator. So now I have 2.3 minus 1.6. This is called your quotient law. So 2.3 minus 1.6 is 0.7. Alright, now I have 5a, which is just saying 5 times a. So log base a of 5 times a, if it's separated by multiplication, you can, if in your argument you have multiplication, you can separate by addition. Okay? So we could just evaluate this log right here. There's an exponent of 1, an exponent of 1. 1 divided by 1 is 1. Plus, we already know what log base a of 5 is. That's 2.3. 2.3 plus 1 is 3.3. And then lastly, we have 3 over a squared. Log base 3 of 3 over a squared. There is division, so you can separate by subtraction. Then you have an exponent of 2, so you could bring that to the front by your power law. So log base A, what was it? I accidentally put it 3. Log base A, log base A, log base A. Log base A of 3 is 1.6 minus 2 times log base A of A. I just realized we actually probably could have just evaluated it here. Exponent of 2, exponent of 1, it's 2 over 1. Right? So then that's just 2. So then 1.6 minus 2. Or if you did want to use the power law, it would be negative 2 times 1, which is just negative 2. You get the same answer. So 1.6 minus 2 is negative 0.4. Okay. So that's question 2. Now for question 3. Which of the following is larger? Log base 3 of 28, log base 4 of 63. So let's list out our, let's say 3 to the x, which is the inverse of a log of base 3, and 4 to the x. Let's list out those inverses. If we actually want to show the inverse, I could also show it like this. Alright, so for 1, 3 to the 1 is 3. For 2, 3 to the second is 9. For 3, 3 to the third is 27. For 4, 3 to the fourth is 81. Now for 4 to the 1 is 4. 4 to the second is 16. 4 to the third is 64. Okay? So, if I wanted to rewrite this as my logarithms, I would switch my input and my output, right? So now this is my x's, and this is my log, or my outputs. This would be my x's, or my inputs, and this would be my outputs, right? That's why I wrote it in that order. All an inverse is switching x and y. So of 28, that would fall between 27 and 81. So the log would actually give you something between 3 and 4. So log base 3 of 28 is between 3 and 4. For 63 of log base 4, that would be between 2 and 3. So that means that log base 4 of 63 is less than log base 3 of 28. So the larger one would be log base 3 of 28. Okay. Now, it says, find the exact solution for the following. We have logs of the same base separated by subtraction. So like we did before, you could use your quotient law, just in the reverse order of what we did before. So that would be your quotient law. So divide has to be the first term over the next term. And then a log without a base shown is called your common log. That would be base 10. So the inverse of log base 10 is going to be 10 to the x. So I have x plus 2 over x equals 10 to the third. Now, what I could do is I could try to manipulate this, multiply by x. So I have x plus 2 equals 1,000 times x. I can I'll subtract x. So I have 2 equals 999x. And then I would divide by 999. X equals 2 over 999. Check that. Yeah, that's right. All right. Okay. So now for B, I have plus log of x. So that is my product law. So that's the same as saying log of x times x minus 3 equals 1. I can multiply out the x. So that's log of x squared minus 3x equals 1. Again, this is your common log. So that's base 10. Could say that x squared minus 3x equals 10. Hopefully it's factorable, but it's a quadratic. So I'm going to want it to equal 0 regardless, otherwise I'll use quadratic formula. And now 5, this is a negative, so it's different signs. The factors of 10 that subtract to 3 would be 5 and 2. So negative 5, positive 2. And your two solutions would be x equals positive 5 and negative 2. Okay. Again, you're just using the same laws that we just practiced. In this case, it was your product law. Okay. So now we have these exponentials. And honestly, with exponentials, you don't even really have to use logs if you don't want. You could just use your method of common bases. So 2 is going to be your common base. So we have 2 to the 2x plus 1. 2 to the third power is 8. So I just substituted 8 for 2 to the third, or really manipulated because it's the same thing. And now my exponent law is the product law. You could multiply your exponents when there's an exponent within an exponent. So we have 2 to the 2x plus 1 equals 2 to the 9x. My method of common bases, if I have a common base, I could drop the bases and set the exponents equal to each other. Subtract 2x. 9x minus 2x is 7x. Divide by 7, and I get x equals 1/7. Okay. I'll let you practice D because it's essentially what we just did. In this case, let's check out E. X squared times e to the x minus 2 times e to the x equals 0. Something you could do, you could factor out the e to the x, and you would have x squared minus 2 equals 0. And now, to solve this, you could use your zero product law. E to the x cannot possibly equal 0, right? Because e is approximately 2.72. To a number that's non-zero to any exponent, dividing or multiplying, you cannot get 0. So it can't equal 0. Now this is not a difference of perfect squares, so you cannot factor it, but you could just solve because it's a binomial without the linear term. So you would add 2 to both sides. We get x squared equals 2. Take the square root of both sides. Remember, you're taking the square root of an unknown, so you must include both plus or minus. And we get x equals plus or minus the square root of 2. And that would be your answer for E. Okay. Now for 5. Given the following equations, find all the solutions in the interval 0 to 2 pi in radians and all solutions in radians. Find all solutions in the interval 0 to 2 pi in radians. Okay, I see. Let's see this. Okay, so we have this factored form, right? So that means you could use your zero product law. Set these equal to 0, right? Zero product law. If you have all factors, then they could all equal 0. If one of them equals 0, then the whole function zeroes out. So I'm going to add radical 3 over here, and I'm going to divide by 2. So I get sine of x equals radical 3 over 2. So on the unit circle, when does sine of x equal radical 3 over 2? So if we remember our unit circle, right, we have pi over 6, pi over 4, pi over 3. And then the way you can memorize it, 3, 2, 1, 1, 2, 3, all over 2. And they all have radical in the numerator. The reason we don't include it on the 1 is because the square root of 1 is just 1. and our x values are cosine, our y values are sine. I'll use the theta, just so you know I'm talking about the angle. So when is sine, the y value, radical derivative 2? Oh, look at that. It's at pi over 3. So x equals pi over 3. Find all solutions in 0 to 2 pi. So, as you know, all students take calculus. All the trig functions are positive. Here, only sine and cosecant are positive in quadrant 2. So, the angle with the reference angle of pi over 3 in quadrant 2 would be pi minus pi over 3. So pi minus pi over 3 is the same as saying 3 pi over 3 minus pi over 3, which would be 2 pi over 3. Here, sine would be negative. Here, sine would be negative. And that's from 0 all the way to 2 pi. So that's your two solutions for this factor. Now I have sine of x minus 2 equals 0. I can add 2 to both sides. Sine of x equals 2. 2. If I wanted to try to solve this, I could take the inverse. This isn't a calculator question, though, but I'm going to check it out in the calculator. So sine inverse of 2 does not exist. It's not within the domain. And if we think about that, actually, it makes sense, because the basic trig function oscillates between 1 and negative 1. So it would never reach 2. So sine of x can equal 2. So these are your only two solutions between 0 to 2 pi. Okay. So now I have 2 sine squared of x plus sine x minus 3. And it might help you to think about it like this. 2 sine x squared plus sine x minus 3. Or it might help you to label it as, let's say, u equals sine x. You really don't have to do this if you're comfortable with dealing with just the sine x, but it will look a lot more like a quadratic if you substitute for just a single variable. Alright, so now the way I would do this is the AC method. Multiply, because it's a leading coefficient other than 2. So now I have u squared plus u minus 6. Let's factor the new trinomial. There's a negative, so it's different signs. Factors of 6 that subtract 2, 1 would be 3 and 2. So we would have positive 3, negative 2, because we want positive 1. And now, because we borrowed the 2, AC method's also called borrow payback, we have to divide by what we borrowed, simplify those fractions. Any remaining denominator will move to the leading coefficient of the respective binomial. Alright, now we just factored this, alright? Let's just sub back in sine. So I have sine x minus 1 times 2 times sine x plus 3, and we're trying to find where this equals 0. So we're going to do essentially what we just did. We just used our zero product law. Sine of x minus 1 equals 0. Add 1 to both sides. You get sine x equals 1. Between 0 to 2 pi, when does sine of x equal 1? Right? Remember, sine is your heights on the unit circle, right? So that's going to be at pi over 2, and that would be at 3 pi over 2, right? So x equals pi over 2 and 3 pi over 2. That's for that factor. Now for this question. For this factor. We have 2 sine x plus 3. So we could set it equal to 0. I'll use a different color so we could differentiate it a little better. 2 sine x plus 3 equals 0. Subtract 3. Divide by 2. Sine of x equals negative 3 over 2. That's saying negative 1.5. Will the height ever be greater than 1? No. So that's impossible. These are your only two solutions here. Okay? So now for this last part, we have tangent squared x minus 1 equals 0. You can add 1. Tangent squared x equals 1. So then you could take the square root of both sides. When you take the square of an unknown, you must include plus or minus. So we have tangent of x equals plus or minus 1. So then, when does tangent equal plus or minus 1? Tangent is sine over cosine, right? So in order for tangent, and let's separate this. Just give me the tip of my pencil's coming off. Sine of x equals, let's say, negative 1. Sine of x over cosine. Sine of x over cosine equals positive 1. That means that sine of x and cosine of x equal each other. And the only place that happens on the unit circle is at 45 degrees, or pi over 4, right? So remember, all students take calculus. In the case of quadrant 1, sine and cosine are both positive. So we would have pi over 4. In the case of quadrant 3, which this is tangent, so you could also know just from it being tangent, but they're both negative. Negative divided by negative is positive. So it's going to have this reference angle of pi over 4. And you could either add pi to it or subtract pi from pi over 4. So pi over 4 minus pi, it's like saying 4 pi over 4. You would end up getting it's the reference angle is pi over 4. Yeah, it's pi plus pi over 4. So that's like saying 4 pi over 4. 4 pi over 4 plus pi over 4 is 5 pi over 4. So that would be your solutions for 1. But now for negative 1. That would be when sine is positive but cosine is negative, and when cosine is positive but sine is negative. So the reference angle is pi over 4. That's when you would do pi minus pi over 4. We have 4 pi over 4, which is minus pi over 4 is 3 pi over 4. And then also, we have, and by the way, I meant to put curly brackets. We could do 2 pi minus pi over 4, which is 8 pi over 4. 8 pi over 4 minus pi over 4 is 7 pi over 4. Okay, so for this question, you had 4 solutions, because we're looking for all the solutions between 0 to 2 pi. So x equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay. Question 6. And this is a calculator active question. Solve for the x accurate to 2 places if x is in terms of 0 to pi. I know for your specific class, you're not supposed to use a graphing calculator, but it says for this department final that it was a graphing calculator active question. So go to y equals y1, type in sine of 4x, y2, type in ln of x plus 2, ln of x plus 2. We're going to graph these. Let me just make sure I am in radian mode. I'm in radian mode, good. And then I'm going to make sure I'm in zoom standard. All right. So I see this sine function. I see something like this. I see a sine function, and then I see a logarithm that goes like this. It might be tangent right here. So it looks like this. So I want to solve for x accurate to 2 places between 0 and pi. So what I'm going to do, I'm going to go to window. So window, and make my x min 0 and my x max pi. 0, pi. I'm going to graph that. So now what I see is something that looks like this. Okay, so I see that one intersection point. There might even be 2. So I'm going to do second, solve for x accurate to 2 if x is in the interval. Okay, like I said, there could be more than one point. Second trace, intersect. I'm going to scroll to the left of where I think the point of intersection is. Scroll to the right, enter, and I get x equals 0.2332749. I'm going to check this second one, see if there's a second one. Second trace, intersect, scroll to the right, near where I think it might be, enter, enter, enter. And that one is x equals 0.4965717. So it looks like for those 2 solutions, you have 0. I'll put approximately 0.23 and 0.49, or you could probably say 0.50. Let me just make sure you're allowed 2 solutions for 6. Yeah, they got approximately that, and they actually rounded to 50. So I guess round up, maybe, if you're given that situation. Okay. So now question 7. For the function below, find the period, amplitude, phase shift, and sketch the graph of one period. So in this first question, this is not in factored form. So we're going to have to pull out that 2 somehow. So the way you could pull it out is dividing by 2, right? It's not difficult. It's just you're probably not used to factoring non-factorable questions. So we have cosine. I would pull out the 2. And now I have x minus pi over 6, right? Because remember, we have just making sure pi over 3 divided by 2. And yeah, 1 over 6, so pi over 6. Just a reminder, and I'll use cosine since you're using cosine. Let's think of every possible case. A times cosine of b times x minus c plus d. A is your amplitude. C is your phase shift, so where it moves left and right. Amplitude, by the way, is distance from the midline to your peaks or your dips. And D, minimums and maximums, D is your midline. Now B doesn't give you something directly, but it indirectly gives you the period, because the period formula is 2 pi over that B. So your amplitude is 6, right? Amplitude is 6. Your phase shift is going to be positive pi over 6. So it's shifting right pi over 6. Rather than starting at 0, it's starting at pi over 6, where we're going to graph. And then your period is going to be 2 pi over 2, which is pi. So what I recommend you do to sketch this, there is something called your sketch point, where we're going to make our delta table, or what you're going to go up by, delta x. The formula for sketch point is period over 4, because we want to separate it into 5 intervals. So we take that period of pi divided by 4, and now we start at the phase shift. So pi over 6. And we're going to go up by pi over 4. Pi over 6 plus pi over 4. Pi over 6 plus another pi over 4. Pi over 6 plus another pi over 4. Pi over 6 plus another pi over 4, right? 1, 2, 3, 4, 5, yeah. Okay? So if you wanted a common denominator, the least common multiple between 6 and 4 is actually 12. So we have pi over 6. That would be, let's think about it. That would be, you'd multiply by 2 over 2. So 2 over 12, and then 3 over 12. 2 pi plus 3 pi is 5 pi. All right. 6 and 4 is still 12. So then 2 pi over 12. And then 2 times 3 is 6. So then 2 pi plus 6 pi is 8 pi over 12. And now for this one, multiply by 2 again. So 2 pi over 12 plus 3 times 3 is 9. 2 pi plus 9 pi is 11 pi over 12. So notice that it's going up by 3 pi over 12. So then this one should be 14 pi over 12, right? Let's just check it. 2 pi over 12, 4 times 3 is 12. So then 2 pi plus 12 pi is 14 pi over 12. All right. If you want to simplify this, that would be even better. So now we have pi over 6, 5 pi over 12, 8 pi over 12 would then be 4 pi over, actually, 12 before. 8, so 2 pi over 3, 11 pi over 12, divide by 2, 7 pi over 6. Okay? So now we have the x values that it would be going up by. So, and where to start? So we have pi over 6, 5 pi over 12, 2 pi over 3, 11 pi over 12, and 7 pi over 6. Now, there is no d there, right? So we just got the x values. Now we're going to do the y values. So where the plus d is, it's actually plus 0, right? So your midline is going to be 0. So this is going to be your midline. I always recommend drawing out your midline. And then your amplitude is 6. So 0 plus 6 is going to be 6. 0 minus 6 is negative 6. Cosine looks like this, starting at the maximum. If it was negative cosine, it would start at the minimum. Sine, positive sine, starts at the midline and goes up and around. Negative sine starts at the midline, goes down and around. So this is positive sine because it's a positive 6 right there. So we start at the maximum, go to the midline, go to the minimum. Oh, I didn't start at pi over 6. Start at the pi over 6 at the maximum, go to the midline, go down to the minimum, go back to the midline, and go to the maximum. And then try to draw a smooth cycle. And there we go. That's one full period of your cosine function that's given. Okay? So now, let's do sine. All right. So, for this one, remember what amplitude means. Amplitude means that distance from the midline to your peaks or to your mins. So your amplitude has to be positive if it's distance. So your amplitude is 5, not negative 5. Negative just tells you the trend of the graph, if it's going to go up or down, or how it reflects over the x-axis. All right? In this case, it's not factored again, so we want that 3 factored out. So I have negative 5, 3, I'm going to divide out the 3, x plus pi over 6. So, again, we have our phase shift. In this case, it's negative pi over 6. So it's going to shift right. It's going to shift left because it's positive. So, phase shift is c equals negative pi over 6. Okay? So, remember, this is your b. Indirectly gives you your period. Period is 2 pi over b. 2 pi over 3 is your period. Now to find those points, those nice points that you want to graph, we use our sketch point. Sketch point is period over 4. 2 pi over 3 over 4. You could do keep, change, flip. So 2 pi over 3 times 1 over 4. 2 pi over 12, which is pi over 6. we're going to start at negative pi over 6 and go up by pi over 6. So that actually makes it much easier to go up by, because they're multiples. So start at the phase shift always, and we're going to go up by pi over 6. So then it goes to 0, 1 pi over 6, 2 pi over 6, 3 pi over 6. And we're only showing one full period, so it'll go to 5 points. So now I'll simplify it. Negative pi over 6, 0, pi over 6, pi over 3, pi over 2. All right. So that's your x values. We found the x values. Now, let's start the sketch. We're going to do our y values. Graph your midline first. There is, again, the plus d would be 0 because there's nothing being added to the function. It's not being shifted up. So, draw your midline at 0. I use a dotted line. So, that's your midline, y equals 0. It's going to go up by the amplitude. The amplitude's 5. So, up to 5, down to negative 5. 0 plus 5 is 5, 0 minus 5 is negative 5. We're starting at negative pi over 6. Let's start putting these points in. 0. Start spacing it out evenly. Pi over 6. Pi over 3. Pi over 2. Okay? And this is sine. Remember, sine starts at the midline, goes around, and goes back. But this time there was a negative. So negative sine of x reflects over the x-axis. So it still starts at the midline, but it's going to go down and around. So start at your phase shift, C, right? So that's going to be negative pi over 6. It's going to go down to the minimum, go up to the midline, go up to 5, and go back around. Draw a smooth curve. That's one full period. Okay? So that's how you would do that question. Alright? It does also say be sure to label all your x-intercepts and your maximum and minimum points. These are your x-intercepts, these are your maxes, and this is your min. Alright? Alright. For 8, find the exact value of sine of 15, cosine of 75. So as we discussed, there's different ways to do this. You could use your sum and difference formulas. You could use your half angle formula. Maybe we'll show 2 ways of doing it. So, sine of 15. We know 30 degrees, so let's use our half angle formula. So the half angle formula for sine is sine of theta over 2 equals plus or minus square root of 1 minus cosine of theta over 2. So sine of 30 over 2, we're going to say our theta is 30 plus or minus 1 minus cosine of 30 over 2. On your unit circle, you know that cosine of 30, it goes 3, right? So then that would be 1 minus square root of 3 over 2, right? Because 3 over 2 is square root over 2. That would be plus or minus the square root of 2 over 2 minus 3 over 2. So 2 minus square root of 3 over 2 over 2. Keep change flip. That would be plus or minus the square root of 2 minus the square root of 3 over 4. And then you would have plus or minus square root of 2 minus square root of 3 over 4 over 2, I'm sorry. Square root of 4 is 2. And then that would be your answer, right? All right. Let's do sum and difference for cosine of 75. So, cosine of 75 is the same as saying cosine of 30 plus 45. Now cosine has different signs, so it's a plus sign, so it's going to be negative. And then you're going to have double cosine, double sine. So cosine of 30, cosine of 45, sine of 30, sine of 45, cosine of 30, remember 3, square root of 3 over 2, cosine of 45, square root of 2 over 2, minus sine of 30 is square root of, so 3, 2, 1, 1, 1/2, square root of 2 over 2. So then you have square root of 6 over 2 minus square root of 2 over, they should be over 4. And then that's square root of 6 minus square root of 2 over 4. So we did use the half angle formula here, but I'm pretty sure you're gonna, if you use your sum and difference, you would get the same answer as this. So I'm sure there's a way you could manipulate this to be the same. I'm not quite sure. So, because that's two solutions. So let's use our sum and difference formula. Sine of 15 is the same as saying sine of 60 minus 45, right? So, sine is the same sign, so it's going to be negative, and you alternate sine and cosine. So sine of 60, cosine of 45, minus sine of 45, cosine of 60. So, sine of 60, remember, 3 to 1, 1, 2, 3. So square root of 3 over 2. Cosine of 45, square root of 2 over 2. Minus sine of 45, square root of 2 over 2. Cosine of 60, 3, 2, 1, so 1/2. So then we have square root of 6 over 4 minus square root of 2 over 4, which is square root of 6 minus square root of 2 over 4. Okay. So that's how you would do question 8. I would like to get to question 10. So let me try to do this. Hopefully the video doesn't cut out because it's so long. Find the reference angle for negative 135 degrees. So first I would find the coterminal angle between 0 to 360. So I'm going to add 360 plus 135. 360 minus 135 is 225. So 225 is between 180 and 270. So that's going to be right over here. Right? If you drew your rotational diagram, that would be the 225. Or if you said negative 135, that would be going clockwise, right? Negative 135. Now, the reference angle is the angle in between the terminal right and the x-axis. So we're actually going to use this positive coterminal angle, and we're going to subtract it by 180. So 225 minus 180 is 45. So your reference angle, let's call it alpha sub r for reference angle, will be 45 degrees. So then it says find cosine of negative 135. We know it will have the same numeric value as the cosine of 45, but this we have to consider the sign. So the absolute values would be the same. So cosine of 45 we know is square root of 2 over 2. But now let's consider the sign. So we would do all students take calculus. All students take calculus. In quadrant 3, only tangent and cotangent would be positive. So this is negative square root of 2 over 2. Okay? And now lastly, for question 10, it says if cosine of t equals 4 over 7, and it's in between 3 pi over 2 and 2 pi, which means that it's in quadrant 4, find the remaining values of the trig functions of t, so the terminal ray. Or no, the angle. Yeah, the terminal angle. Okay, the angle created by the terminal ray. So, yeah, okay. So, I mean, if you're just finding the angle, you could use your inverse trig functions. So, cosine of t equals 4 over 7. So then the inverse of cosine, so our arc cosine of 4 over 7 equals t. And then our cosine of 4 over 7 is, what does it want? It wants it in radians, so the exact value. So for 10, it does want the exact value. Oh, it's just asking for the trig functions of t. I see. Okay. So there's really, two things you could do. You could use identities, like Pythagorean's identity to find sine, and then tangent sine over cosine. Or you could do your right triangles. I recommend doing right triangles when you want to find all the trig functions of t. So, let's do the right triangles. It's quadrant 4. You're using the reference angle. So this is where your t will be. And then cosine in SOHCAHTOA is adjacent over hypotenuse. So your adjacent is 4. Your hypotenuse is 7. So then we need to find the opposite. So, use Pythagorean's theorem. 4 squared plus x squared equals the hypotenuse, 7 squared. You could subtract your 4 squared. Take the square root of both sides. X equals 49 minus 16 is 33. So square root of 33. So then sine of t is opposite square root of 33 over hypotenuse 7. Remember, all students take calculus, so it's negative because cosine's only positive there. Cosine is already found, so cosine would be what's given, 4 over 7. Tangent is sine over cosine, but you might as well just use a triangle. Opposite over adjacent, square root of 33 over 4. And then because it is in quadrant 4, only cosine's positive, so it's negative. And then your reciprocal trig functions would be, secant of t, which secant is the reciprocal of cosine. So that's going to be 7 over 4. Cosecant is the reciprocal of sine. So then that's going to be negative 7 over radical 33, which it seems like your teacher likes to have the answers in radicalized numerator form. So I'm going to multiply by radical 33 over radical 33, and you would get negative 7 radical 33 over 33. And then cotangent of t is going to be 1 over tangent of t, or the reciprocal of tangent. So it would be negative 4 over the square root of 33, multiplied by the square root of 33, square root of 33, would be negative 4 square root of 33 over 33. Okay. All right. I feel like maybe we should leave this for you to practice. It looks like it's in quadrant 4, right? You're going to do opposite over hypotenuse. You're going to solve for your adjacent side and then do exactly what we just did. Hopefully this helped. I do plan on making videos for the rest as well, but I'm not quite sure if the video will save at such lengths. Thank you.